get started here pretty soon. And while I do that, if folks have any questions, please don't hesitate to drop them in the Q&A folder in the webinar. And if you want to send an email to webinars@interfacefluidics.com, we'll also receive those and try and address them there. But with that, and no further delay, we'll get started. So today's webinar in Interface's latest series of webinars is talking about subsystems in concert, why Interface Fluidics builds turnkey solutions rather than supplying components like many of the other microfluidics companies out there in the world do. So I'd like to introduce myself. I'm Stuart Kinnair. I'm the CEO and co-founder of Interface Fluidics, and I've got with me today Tom DeHaas, our Chief Technology Officer and co-founder.
Hi, everybody.
As I said, you can submit questions to the live chat or email us at webinar@interfacefluidics.com. So as an introduction, Interface Fluidics is a technology company based in Edmonton, Alberta and Calgary, Alberta. And our goal is to make the interactions and properties of reservoir fluids truly accessible. We believe at Interface that due to the cost and logistics and other constraints of making high pressure, high temperature fluid property measurements, they are a fundamentally inaccessible data set. And that's something that we've been working on at Interface now for almost 10 years. Over the last almost 10 years, we've worked in the oil and gas industry, carbon sequestration, and many other industries to help understand how these fluids behave. And we've worked in reservoirs from Canada, the US, Europe, and then as well as in the Middle East. We do all of our services include frac fluid optimization, enhanced oil recovery, steam-assisted gravity drainage, offshore conventional production, as well as a suite of PVT and phase behavior measurements like minimum miscibility pressure and flow assurance measurements. Now, to set the stage, today we're going to go through and walk everybody in the audience here through the Interface story and how we got to why we provide a turnkey solution today. Now, as some of you may know, we are a spin-off out of the Sinton lab at the University of Toronto. And that's really a breeding ground for state-of-the-art microfluidics. And so we want to walk you through the journey of my co-founder Tom here's story as he went from student to microfluidics proprietor. After that, we'll go through how we've built Sapphire Lab, why we've made the decisions we do, and run you through at the end sort of one system that has many applications. So with that, I'll get going here. Now, some of the questions we're aiming to answer today are, why is Interface a microfluidic chip fabrication company, a hardware company, a software company, as well as being a service provider? We've been doing this for more than 8 years now. We've invested millions of dollars in developing our technology, and we've become the largest high pressure, high temperature microfluidics company on the planet. The big reason we've done all of this is because representative systems and repeatable results don't come out of the box from your DIY microfluidics companies. You have to know how to tune and tweak and develop these systems to be able to get good results. We've been iterating for the last 8-10 years so that you don't have to. And that's where Sapphire Lab comes from. So a brief background on the company as Tom has seen it over the last few years.
Sure. Hi, everybody. So a little bit of the background about how Interface Fluidics started. So myself, I was a master's student at the University of Toronto under Professor David Sinton, who's the third fellow in the picture there. And Stuart was my roommate at University of Victoria. So basically, when I was working at Suncor Energy, we saw that lots of the problems that we had there could be addressed by getting testing done at the University of Toronto through their SAGD steam-assisted gravity drainage testing setup. And I saw bigger and bigger projects relying on data from this setup and thought of this as a problem that didn't really have a commercial solution. So I decided to convinced Stuart and Dave to start up the company here, and then we together founded Interface Fluidics in 2015, and since then it's been a real adventure. So I'll turn it back to Stuart.
Thanks, Tom. So ultimately, what we're providing is what we're calling a turnkey solution, or microfluidics, where you don't have to buy the parts themselves. This is a unique approach in the oil and gas microfluidic space, but it's the most common approach in the biomedical space. And so we've been trying to understand why has it been this way. So the paper on the right there is the first microfluidics paper, one of the first microfluidics papers ever published. And it was for enhanced oil recovery and understanding fluid displacement at the pore scale for enhanced oil recovery. This is what people are still doing today. And this technology was developed originally for the oil and gas sector, and then the biomedical space has really taken it and run with it and developed it over the last 50, 60, 70 years. At Interface, we're taking all the learnings that we had from the biomedical space and bringing it back into the oil and gas sector so that we can try and move this industry forward. Because really, why has this technology not come to prominence before Interface for the oil and gas space? And it's because there weren't holistic systems that were available to be provided to solve this kind of problem. You have to know how to buy all the components. And really where that gets us to is buying or doing HT microfluidics today is a DIYer's nightmare. And we've learned that the hard way at Interface. Microfluidic components all have significant trade-offs when it comes to running a good experiment. What we've seen is that you can't even buy all the parts that you need in order to run these good experiments. At Interface, we've had to develop the core systems ourselves so that we could be able to provide this service to our clients. Like I said, we've learned the hard way how each of these components impacts the running of good experiments. So a few examples here. Syringe pumps. This is the mainstay of almost every microfluidics lab in the world. Interface has bought just about every high pressure, high temperature syringe pump that exists on the planet. And we've landed on just one pump company that delivers pumps that are able to do what we need it to do at a price that's reasonable. And even then, we're still pushing them to adapt their systems to our needs. Microscope cameras. This is an area where you have to stay on top of the technology because it's growing and changing, and every single year there are new cameras with new technologies that improve the measurements that you're making, so you have to be up on it. And lastly, my nemesis, pressure sensors. We've bought just about every single high pressure sensor that purports to have the capabilities that we need, but at the end of the day what we find is either those capabilities are too noisy or not applicable at the pressures or flow rates or different experimental conditions that we need. And ultimately, what we did is partner with a company called Phase Sensors to develop sensors for our application. So again, you're seeing we have to find new applications and new hardware and new equipment that actually meet the needs to run these good experiments. So it's not possible to buy these components off the shelf, not until recently. And so on the left here, you can see these are the main components inside of a high pressure microfluidic system that we offer. And the title of this slide, it takes a village to raise a sapphire lab, because what we've had to do is hire graduate level people in each of those specialties on the left there, just in order to specify and develop these methods. And so the question you have to ask yourself is, if I want to do high pressure, high temperature microfluidics, can I do that with the team and budget that I've got? And often the answer to that is no. There's a lot of stranded microfluidic systems in a lot of places in the oil and gas industry. And it's because it's very difficult to justify and build these teams. You have to have a lot of vision, which I give Tom credit for. So for example, the thing that everybody thinks about when they think about microfluidics is the chips. And at Interface, we are unique in the fact that we offer custom microfluidic device design supply them to our clients, and they all use them, are able to use them at over 10,000 psi, over 180 degrees Celsius. These are pressures and temperatures that are not commercially available anywhere else in the world. And the fact that we can do this faster and cheaper than other microfluidic chip suppliers out there in the world really says something. To give you an idea of the level of optimization here, this is a lot, but what it takes to actually design a chip, you have to have the ability to design these chips in CAD. You have to then know how to print photomasks. You actually have to go get it done in a clean room. You have to optimize your lithography process and understand the constraints there. You have to learn how to drill ports, whether that's with traditional methods or advanced methods. We've tried it all. We've landed on something that works really well, but it took us almost 3 years just to learn how to drill ports well. Beyond that, bonding the systems together, as well as dicing so that you have high yields. All of this requires and has required many years of development. And this is just for the chips themselves. And I showed you that big list of components before. Each of those components has a similar story behind them. And so just to wrap up here, where we've gotten to and the reason we have landed on providing turnkey solutions is we know the barriers that this technology faces, and we've done the learning, and we want to provide our knowledge to the industry so that it's available and this technology can be used because the barriers to using it are high. Now, this is what the microfluidics device systems for the biomedical industry has learned and has optimized for over the past 70 years, and it is the standard way that people buy microfluidics for the biomedical sector now. So with that, I'll turn it over to Tom to talk about his journey at the Sinton lab.
Sure. Hi, everybody. So I'm just going to quickly go through what happens at an academic microfluidics group, what type of exciting things they're up to, and then what differs that environment from interface fluidics and running commercial high throughput microfluidics. So go ahead. So this is a picture of a group of folks over in Toronto. This is back in 2017. A few of the people there are now part of Interface Fluidics. In fact, Dave was with Interface Fluidics when this was taken. The Sinton lab at University of Toronto is really a special place. They've got a bunch of different focuses, with the energy industry being only a small part of that. They also have lots of work in the biomedical space, as well as in electrocatalysis. And so as a result of that, there's been a whole, probably about 5 or 6 startup companies that have come out of his lab, including Interface Fluidics, which is, I believe, the largest of the startup companies out of his lab. So in an academic setting, it's quite different from what goes on at Interface. Basically, one highly trained person or a group of people will manage the entire microfluidic process, from coming up with a concept for a test, concept for a study, fabricating the chips, building the apparatus that you require to run those tests, performing the test, the analysis, and the reporting. This has a lot of advantages because you can have a lot less process and overhead and a lot less people involved, but your throughput is very, very limited and your repeatability is low. Basically, the goal of these studies is to get enough test data in order to publish a paper. And then at that point, you're done and you go on to the next thing. So your setups only need to be robust enough to really run one full set of data, and then you can take it apart and move on to the next thing. However, in a commercial setting, this isn't the case. So the academic one, as it says on the bottom there, there's less consistency between operators. Processes aren't as well documented. In some cases, the instruments aren't calibrated on a regular basis. Data is not stored for a long period of time, and the throughput is much, much lower. So a few other things that are different between an academic setting and commercial, the biggest one and the one that we see again and again at Interface is that in an academic setting, you're selecting often fluids that work with the limitations of your equipment. So if you know that you want to publish a paper on phase behavior and your chips only go up to 40 bar pressure or a few hundred psi, you'll select a set of fluids that work within that pressure range, don't have any contaminants or particles in them, and you can publish a really lovely paper. However, this isn't possible when clients are sending you samples that you can't control. So in Interface, we have to design equipment to handle samples from all over the world with different properties. And I would say that this is where a very large part of our development goes, is that we spend the first couple of months getting it to work with model fluids, and then the next year or 2 years getting it to work with client samples. And that has led to our commercial products that we have today. The other difference is that you have very highly trained PhD level or master's level folks that are running all of your analysis. Sort of, each set of pictures is handled through one person, and that person has to be highly trained, come up with scripts or very rudimentary things in order to run each set of analysis. But if you wanted to train another person on how to run your weird Python script that you've built, it might be really hard. The equipment is often built for purpose and difficult to operate without standard operating procedures there as well. So Interface Fluidics has still a very close relationship with Sinton Lab at the University of Toronto. A couple of the key things that come from there is, first off, lots of really excellent microfluidics training. So we're bringing folks into the company that are coming out with a PhD or a master's in several years of experience handling very similar equipment to what we do. The advice from Professor Sinton there is always welcome and keeps us on track for getting all of our development working. And the two groups sort of serve very different needs. If there's a very new idea that has never really been proven and you don't even know if it's possible with microfluidics, the academic setting is a great place to sort of take those extremely high risk ideas and put them through the meat grinder and see what comes out, publish some papers, and then once things are sort of pointed in a direction that seems there's commercial potential, it can, with the right licensing and such, end up as a commercial application in a company like Interface Fluidics.
Yeah, one of my favorite examples is there was an organization that came to Interface looking to understand a complex fluid for one of their processes. We basically said, this is too risky for us to take on right now, but here's Sinton Lab. Sinton Lab then went on to have a very fruitful relationship for over a number of years with that organization, proved out their technology really well. And while Interface isn't working with that organization to test their fluids, we've managed to hire great people out of that project. And that's been, just one example of the process there.
Yeah. Yeah, so these are some of the non-interface successes that have come out of Dave's lab. So on the bottom left there is a company called CERT that's doing CO2 electrocatalysis, converting CO2 into things, I guess in this example, shampoo and lawn furniture. There's also lots of different CO2 air capture work that's happening there. And then also some things on the biology side that aren't listed here.
Excellent. So the next topic here is Tom's going to he's been on the front lines dealing with developing all of these different subsystems that allow us to do what we do. So I'm going to walk you through some examples of what those are. But first,
Sure.
This is what we've ended up with at Interface. So this is Sapphire Lab. It's a high pressure, high temperature capable microfluidic system. This is just a rendering, but that does exist. The claim to fame for this piece of hardware is Interface worked with a company called Enhance Energy last year. That hardware ran more than 250 slim tube equivalent experiments or gas injection experiments. That was likely more experiments than was done by the rest of the oil and gas industry for that purpose in the last, at least last year, if not last 5 years. We did that in just 3 weeks. So that's sort of illustrates the benefits of the technology.
The valves there on the right, the first system that you saw the rendering of was a system that had automated valves. This one, they're all manual. We've enclosed all of the valving tubes inside of the system. There's high pressure pumps and pressure sensors. This particular unit will go up to 5,000 PSI. And the last part that's really, really important is the software, which is really what controls everything in this setup and makes everything work together. And we've developed a data pipeline for each individual test, so that all the way from getting a chip, putting it into the system, through to getting results, your hand's sort of held all the way through, and you don't need to go and attend Sinton Lab to go get your PhD in order to solve these problems. So the three applications that we use in our setups is Auto Bench, which is the system that automates the hardware. Auto Analysis handles the image analysis, and the Portal, which is a cloud-based lab management tool. And I'll just quickly show some examples of this. So this is a minimum miscibility pressure test being run on a instance of AutoBench. You can see that there's a part for collecting data with the microscope, and then there's this screen here has all the sort of text display, but then there's also a version that has all the plots for all the different pressure sensors, temperature controllers, and all the parts of the system that you'll need. So yeah, if you click through, yeah. So this is Auto Analysis, which is the second product. Here, this is one of the two screens. So this is called our project test view. You can go through, and this is something that I'm sure would be loved by lots of the grad students out there, is you can quickly go through and look at all of your different projects. That's just blurred out here because they're all client names, and select which test you're running, which run, and then you can view all of the pressure logs, temperature logs, and volume measurements. And this is all plotted relative with the gray region there being the frames of the microscope image. So you can basically scroll through, see what your pressure, temperature, volume are doing at all of the different over time, I guess, and it's correspondent to the images. This is used a lot by our microfluidic development team. The other things that this program will do is a fully automated analysis for all of our commercial tests. So this includes flowback, regain conductivity, and minimum miscibility pressure. So the program will, with very minimal user input, guide you all the way from starting an analysis through to getting your oil saturation over time, volumes, contact angles, all that different stuff will all be analyzed in this program. And we're adding new tests regularly. I'm sure that Stuart's got a big list of things that he wants to get out into the world. We've got some stuff that's being tested, and I'm sure there'll be a webinar about those new tests as they come out.
Absolutely. Last piece here.
So this is the portal, which is really a program that lets users log in and see all of the different tests you've run before, what's going on in the lab, the status of all the equipment, which samples are run on which tests. This here is an internal minimum miscibility pressure test that we ran, and you can just quickly go through each test and see exactly what the oil displacement was versus pressure. This is the slim tube equivalent minimum miscibility pressure test that we've developed. Yeah, go ahead, sir.
For folks to know, this is a cloud-based software that allows anybody anywhere to log into their company's dashboard, see results in real time as they come off the hardware. So you can have someone analyzing and understanding the information that's being generated, while someone somewhere totally different is actually performing the experiments. It allows people to collaborate over great distances.
So there's a lot that has gone into building this system. Basically, you have to think not just about what are the individual pieces of the puzzle that you can buy with the biggest specifications in order to solve the problem, but you have to think really about what you're trying to get out of each individual test. There's often conflicting requirements that you have to build out in these different systems. And so some of those key considerations are that you need to have a test that can run for a certain amount of time while minimizing your dead volume. So you want a big syringe to run for a long time, but you can't have too big of a syringe or else your system will have high volume, which has a bunch of drawbacks. There's concerns about minimum flow rate versus pressure. Some of the pumps that offer extremely precise minimum flow rates have low maximum pressure, which is a concern. Pressure measurement accuracy versus pressure range. As with any sensor, the bigger the range, the lower the accuracy in general. So you have to select those appropriately. Some of our different chip holders have the benefit of quickly changing the chips out, but they might have lower maximum pressure than others. And then the amount of system that you can heat up versus the complexity. This has been something that has become very apparent, is that the more heating that you want, the more parts of the system you want to heat up, the more complex the system can get. And so
Great. Thanks, Tom. So the last piece of this webinar today is to run through sort of, this may be one system, but it has many applications. And the place to start here is to talk a bit about our process. Like we said, we've been developing this for almost 8 years now. And this is just a timeline of some of the things that we've had to do over that period of time. So when we started the company, the interface was limited to 50 bar, just a couple of hundred PSI, which, to be totally honest, we realized very quickly that's a fairly useless pressure for anybody who cares about commercial reservoir pressures and temperatures. So you can see that number progressively increased year over year until now we've got to a point where interfaces pressure limitation is kind of a thing of the past. If a client needs us to hit a specific pressure, we can hit that pressure. It says 750 bar on here. That was 2021. Since then, we've gone to increase it well above that. You can see it takes years to develop these measurements as we go through here. So we started developing our flagship product today, which is our PVT measurements that are just becoming commercial. We started development on that suite of products in 2017. And it's taken us this many years just to get to the point where we're able to offer these to our clients. And so where we are today is, we've been fortunate enough to be featured in Journal of Petroleum Technology a number of times for individual measurements that we've made that frankly add a lot of value to the industry as individual measurements. So now we have applications in hydraulic fracturing, formation damage, whether that's in shale, offshore, onshore, really doesn't matter. We're focused very heavily on phase behavior and fluid properties these days. We've developed enhanced oil recovery measurements for polymers, surfactants, foams, nanoparticles, just about anything you can imagine. We're working in carbon storage and carbon sequestration, as well as custom studies. So people often reach out to us and say, I've got a fluid problem that I just don't know how to solve, but this technology looks like it might be able to help us. And so the ability for us to develop new custom capabilities that they benefit from, and then we can offer those to other folks in the world who might have that same problem. And just to give you an idea of all of the different systems that Interface has integrated into one microfluidic system, if you were to buy, if you wanted to buy all of the capabilities that we have in Sapphire Lab as separate machines, which is how it's done today, you have to buy in the top left here, this is a slim tube. You can see a video of the slim tube equivalent that we've developed for our microfluidic system. This is more accurate than the traditional method, much faster, uses lower volumes. On the bottom left here, you can see the way people measure emulsion characteristics is putting them in beakers, shaking them up at atmospheric conditions. What we've done at Interface is develop a system that lets you understand emulsions at your system temperature and pressure, whether that's very hot, very cold, and everything in between. On the top right, this is a formation damage tester. So people are looking at permeability damage to formations, and we've got an image coming out of our what formation damage, how it manifests in our microfluidic systems. And then the bottom right, sort of the gold standard of the oil field lab, is your core flood. And our application on the bottom right here this is an example of what a core flood looks like on a microfluidic system. We've been able to validate that our results line up and are predictive of what you get out of a core flood in many cases. So there's the ability to take all of these very expensive machines and put them onto one system and run all of these experiments all at the same time really is the beauty of microfluidics. So with that, I just want to wrap up here and say thank you. But the take-home message here is, if you're trying to do high pressure, high temperature microfluidics, I fundamentally believe that if you're buying components off the shelf, this is holding you back. You wouldn't build a car just so you can commute to work. You go to the experts, and those experts come from places like the Sinton lab or at Interface, where we've been developing this for the last many years. We've spent a lot of time developing and optimizing Sapphire Lab, not for academic applications, but for the real world and the real commercial applications. And what we've ended up with is a portable microfluidic system that is capable, flexible, and easy to use for almost anybody. And the last thing I'll say here is that all microfluidic systems are in fact many subsystems that have been developed and optimized, working in concert to bring you the high quality data that you expect from Interface Fluidics. So with that, I'll say thank you very much and open the floor up for any questions that might have come up. While I wait for any questions to come in here, Tom, can you maybe share some experiences? People love hearing about the things that we struggled with over the years. Is there anything that comes to mind where I think we learned the hard way?
Yeah, I mean, I would say that the biggest one has been definitely a number of years ago, learning which pump flow rates are the reasonable ones that you can trust. So there's definitely an issue where if you're running experiments with extremely low flow rates, and you purchase pumps like we did at that time that had very large volumes, in some cases the temperature change in your lab of a few degrees Celsius can result in a volume change that's actually substantially larger than your flow rate. So if you're measuring a flow rate out of a pump, and you can come into weird situations where you're pumping fluid into a chip and your pump is actually retracting backwards, and you're reading a negative flow rate, but you can see things running forwards, and then you realize that there's problems. And so Interface has spent a lot of time to go through and measure flow rates on our microfluidic chips as a result of that. And so in all of our studies where there's flow rates that are, well into the nanoliter per minute or nanoliter per hour range, flow rates will be measured on chips so that you can have certainty about what you're actually doing.
If you come into the lab and visit us at Interface, you'll see a big sign on the wall that says, "Don't trust the pump."
Yeah, don't trust pump flow rates unless Exactly. You've done all the work to realize you should. So
yeah. Well, with that, folks, thank you very much for joining us today. This webinar will be posted to YouTube if you want to review the topics that were discussed or have any questions later. So thank you very much and have a great afternoon.